I'm going to call this one a math exam skill. It's not necessarily going to be a standalone question, but it is essential when working with series, power series, things like this. So the question is this: perform an index shift on the series, the following series here, so that the new series starts at k equals 1. Notice now that it starts at n is equal to 4. So we want something that says sum as k goes from 1 to infinity of some other statement. And we want those two things to be equivalent. All right, let's go through the walkthrough here. So the important part here is knowing that you have to establish a relationship between the n values and the k values. Once we do this, then it's mostly just algebra and replacing all the old values with the new values. So what do we want to happen? We want to happen that when n is 4, k is equal to 1. So we want a way of relating k and n together so that when n is equal to 4, k is equal to 1. All right? And we can come up with that with just basically some guesses, but that's the important thing to know. And so we come up with this relationship here. When n is equal to 4, k is equal to 1. Of course this works, right? With a couple of practices you're going to see, it's not too hard. And really this is the important part. This is the whole thing. Because from that point on, we're going to be subbing out. So remember our original question was here. Now we need to take all our n values and replace them with k values. Well, we can do that now because we have a relationship. We had k is equal to n minus 3. Well, we can solve for n is equal to k plus 3. Now all we have to do is we start subbing in. So this is very wordy here on the website. That's because I want to give a full explanation of what's happening in plain English. So here we have the original statement, an, and we're just going to replace them all with ak's. So 2 to the n becomes 2 to the k plus 3, because as you remember, we had that relationship where n is equal to k plus 3. So you can replace all the n's with k plus 3's, and then we just solve here. There's not much to solve. It's just basically nothing. And then you have to remember, of course, that the bound of the sum now is k from 1 to infinity of this new statement here. So that's a very great skill to have, and something to practice. Definitely something to practice. Now let's see if I can scroll down a little bit here. What's the last one? Oh, it's just the conclusion, I think. Performing an index shift on this so that the series starts at n equals 1 yields the series, and then that's the final answer. And of course, as you're working through this, if you want to just test yourself and you don't want the whole walkthrough, you can just see the solution as well. Boom, there you go. Hope this helps. I'm Sheldon. I show you how to solve mock and modified past exams to first year university math courses.